On a problem like this one, for example, this is number 21, what you want to do first is you want to write these as problems with the same base. So that 81 is a power of 3, because if I do the prime factorization of 81, that's 3 and then you have 27, that's 3 and then you have 9, 3, 3, 3, 1. So that's basically 3 to the 4th power. So I can rewrite that as 3 to the 4th power times the 5th root of 3. Then I'm going to write this as a rational exponent, because if I write them as rational exponents, I can actually use the properties. So this is 3 to the 4 over 5 times 3 to the 1 over 5. Because there's a 1 right there that you don't see because it's not there, but 3 to the 1 is 3. So what I'm going to do is now I'm going to use the properties of exponents, and I have 4 over 5 plus 1 over 5, because when you have the same base, you add the exponents, 4 over 5 and 1 over 5. So this is 3 to the 5 over 5, which is 3 to the 1, which is 3. And so your answer is just 3. And the same thing is what you're going to do, very similar to problem number 24. Now again, what I'm going to do with 24 is I am going to do the prime factorization. Actually, this is 25. I'm going to do the prime factorization of 28. That's 214, 27, 7, 1. And so that's 2 squared times 7. And I am going to break this down. So this is the cube root of 2 squared times the cube root of 7 over the cube root of 2. So now I'm going to rewrite these as rational exponents. So 2 to the 2/3 times 7 to the 1/3 over 2 to the 1/3. Now, these two have the same base. And when you have the same base divided, you subtract the exponents. So what I'm going to do is I'm going to do 2 to the 2/3 minus 1/3 times 7 to the 1/3. So that's going to remain as that once I'm done. And so this becomes 2 to the 1/3 times the cube root of 7, and that goes back inside because that's the cube root of 2. So you end up with the cube root of 14. And that's because you multiplied that 2 with the 7. And so that's your answer.